Okay, back again. So this time from your molecule kit, you're going to want an oxygen. And oxygen is red. Just think of when your blood is oxygenated, it's bright red. So that's why we use red for oxygen. And we'll need 2 hydrogens. So I've got my 2 hydrogens here, my 1 oxygen. And then we need 2 sticks. So I'm going to put those 2 sticks in the oxygen. And then we'll put the hydrogens on. And this is the shape. So notice I said it was a flat molecule, so this time all of the atoms, the oxygen and the 2 hydrogens, fit in the palm of my hand. It's flat, it's planar. So, it'll lie flat on the desk. Unlike the ammonia, the pyramid, and unlike the tetrahedron. So now this oxygen, again, doesn't have enough holes for me to show you the lone pairs. So what I'm going to do is bring back our friend tetrahedron. And we'll put those lone pairs in. So these are the lone pairs of electrons that don't have anything bonded to them. And then these are the parts where the hydrogen is bonded onto the atom. So notice it is identical to that. So with lone pairs, a tetrahedron, with 2 lone pairs, a tetrahedron becomes a bent molecule shape. Now, this is the key to water's marvelous properties. In fact, if there wasn't water on this planet, there wouldn't be any life on this planet. Water is a crucial component of life. Think about it this way. You're 80% water. So why do you suppose this is a polar molecule? Well, again, oxygen is very electron hungry. It has high electron affinity. And this is Arnold Schwarzenegger. This is Pee Wee Herman. This is Pee Wee Herman. Now, if you're playing tug-of-war, in this arrangement, as Pee Wee Herman, you have no chance of winning. Okay? So it's a polar molecule. So the oxygen, being electron hungry, gets more of hydrogen's electrons share than hydrogen does. So we have a negative region at the oxygen, and we have a positive region at each hydrogen. It's a polar molecule. So here's a silly joke. Why do white bears dissolve in water? Because they're polar. Anyway, so let me show you a case where oxygen, and which is a very electron-hungry element, actually doesn't win the tug-of-war. Let me show you one more example of a non-polar molecule that has oxygen in it. Generally, most molecules that have oxygen or nitrogen in them are going to be polar. We'll talk about the importance of that in a little while, but I just thought that first we'd look at how we get these shapes.